So this video is about solving polynomial inequalities. So we'll be going over different ways that you can solve these guys. So I guess the first question is, what is a polynomial inequality? So what polynomial inequality is instead of your equation having an equal sign, like you usually have like a bunch of stuff over here equal to a bunch of stuff over here, instead of having an equal sign between them, the sign that you'll have is a greater or smaller than sign. So the signs like these. So you have either one of these two signs, or you have this one with the little line at the bottom, and the one that goes the other way around. So any single time that you see these guys, one of these four, instead of your normal equal sign, it is a polynomial inequality. So when we're solving these, the values that we're looking for are not actually going to be the values that make the left side equal to the right side, but we're looking for values of x such that the left side is smaller than the right side. So if you kind of think about it, there could be many different numbers that are possible. So when we solve these guys, our solutions are not going to be like one or two numbers. They're actually going to be like an entire range of numbers, like entire intervals of numbers, like numbers between like 1 and 4, or numbers between -5 and 8, stuff like that. Okay. The way we solve one of these inequalities is going to be the exact same way as solving polynomial equations. Meaning we're going to pretend there's an equal sign over here, and we're going to solve it just like it was a polynomial equation, and then we're just going to do one extra step afterwards, and that'll be able to get us our range of numbers. Okay. So let's do this. I'm going to move this stuff over here. That we have more room. Okay. So if you pretend there's an equal sign, the first thing you do is you want 0 on one side and for everything else on the other side. So we're just going to move these guys over. Minus x squared minus 5x plus 14 smaller than 0. Alright, and then we collect like terms. Minus, is that 3x squared? That's 3x squared. And then minus 4x. Plus 12. Smaller than 0. Hey, awesome. So we're just going to factor this and get our solutions. We're still pretending it's an equal sign, not a less than sign. Okay, we're just going to factor this. Okay, so all possible factors. Since there's a 1 in the very front, all our possible factors are just going to come from this number, 12 over here. So, 12. 1, 2, 3, 4, 6, and 12. Alright, so time for the random substitution stuff. So after some testing, we found out that 2 works. We plugged in 2, 0. That means x minus 2 is a factor. Okay, so let's do our synthetic division and get the rest of our polynomial over here. So we have 1, -3, -4, 12, 2, 1. 1 times 2 is 2. -3 plus 2 is -1. -1 times -2 is -2. -4 plus -2 is -6. -6 times 2 is -12. That equals to 0. Okay. So in our brackets over here, we have x minus 2. And then x squared minus x minus 6. Okay. And since we have a quadratic over here, you can just factor this quadratic like our usual method, or whatever method that you choose. I like to do crisscross. Okay, I'm actually just going to do this. So we have x minus 2, we have x minus 3, x plus 2. Sweet. So each of the solutions here are going to be x equals 2, 3, and negative 2. Awesome. So here's where the inequality part comes in. We solve this just like we did a polynomial equation, but we're not looking for numbers that equal to 0. We're looking for numbers that make this guy less than 0. But the numbers that we got over here, our solutions, are going to help us determine what those numbers are. All the different intervals and different ranges. Okay. So there's a couple ways you can do this. The first way we can do is we can factor. The first way we do is we can graph our polynomial over here. So if we graph this, if you remember from graphing polynomials before, each one of these guys are x-intercepts. Each one of these guys are x-intercepts over here. So we have 2. Oh wait, negative 2. 2. And 3. Since this is degree 3 and it's positive being coefficient, we have quadrant 3 going to quadrant 1. I'm going to write over this. So the function looks like this. So the good thing about graphing is that there's a lot less thinking for me. Okay, so now that we graph this, we're basically looking when this guy, since we graph this one, is less than 0. So in our graph, what that translates to is the part of the graph that's under the y-axis. So I'm going to do this. Do this in a different color. So the part that's under the y-axis is all of this stuff. All this stuff over here. So the areas, so how this translates to our graph is we're looking for when this is smaller than 0. So how this translates to the graph is everything that's under the y-axis, so under the x-axis. So since this is the x-axis over here, we're looking for the parts of the graph that are under it. So in this case, that would be this guy, and that would be this guy. These two parts. So these two parts are when x is smaller than negative 2. So any x number we choose that's smaller than negative 2, this thing is going to be less than 0. As you can see, it goes below the y-axis. So any number we choose, like negative 3, negative 4, negative 5, all the way to infinity, x minus 2, x minus 3, x plus 2 is going to be smaller than 0. The same thing goes for any number we choose between 2 and 3. So if you choose like 2.1, 2.2, 2.3, 2.4, 2.5, we substitute in here. Since our graph is below the x-axis, it's going to be less than 0. So the way we write this out is using interval notation. So our solutions are x. Use this little sign for equals. So x is an element of, we can choose x as any number between negative infinity to negative 2. So all the numbers less than negative 2. And the reason we use round brackets is because round brackets represent all the numbers less than negative 2, but not including this number. And the reason why we don't want to include negative 2 in our solution is because we're looking for numbers that cause this guy to be strictly less than 0. Since negative 2 causes this guy to equal 0, as you can see here, we don't actually want to include negative 2. That's why we use a round bracket. If, let's say, for example, we had this instead in the beginning, let's say instead we have a less than or equal sign. Since we're including numbers that make this guy equal to 0, we're actually going to include the number negative 2 in our interval here. So the way we do that is we use a square bracket instead. So if we have less than or equal to 0, then we want to include the point negative 2, and the way we notate that is using a square bracket instead of a round bracket. Okay, but since this case it's not like that, then we're going to use a round bracket instead. Okay, so that's this part of the graph, and the other part of our graph is between 2 and 3. So we can use 2 and 3. And once again, we use round brackets because we don't want to include the points 2 and 3. 2 and 3 make the function equal to 0, make the polynomial equal to 0, but we want strictly less than. Awesome. And the way we join these guys together is we use a little sign, a union sign. So this means our solutions are going to be when x is in between negative infinity and negative 2, or when x is between negative 2 and 3. And this is the way you solve polynomial inequalities used graphically. Okay, let's move on to the other way of doing this. We're going to get the exact same answer, it's just in a different way, depending on what your teacher wants you to do. Okay, so the next thing, the other way you can do is to use a interval line. So what that means is we're going to draw a line over here, a number line, negative to infinity. And what we're going to do is we're going to put in these numbers here, negative 2, 2, and 3. Awesome. So what we're going to do, the reason why we're doing this, is we have these intervals here that are divided between these numbers, right? So we're going to plug in a number between negative infinity and negative 2 into our function and see whether or not it comes out as positive or negative. And it can be any number. So in this case, the simplest number between negative infinity and negative 2 is 0. So if we plug in 0 into our function over here, what we're looking for is not what value comes up. We're just looking for whether or not the outcome is a positive or negative number. And what that's going to do is it's actually going to tell us if the entire interval is going to be above 0 or below 0. So let's show you an example. So if you plug in 0 into our function over here, x minus 2, 0 minus 2 is a negative number, 0 minus 3 is a negative number, and then 0 plus 2 is a positive number. Okay, so the reason why we're doing this is we're going to substitute a number between negative infinity and negative 2. So any number will work. Negative 3, negative 4, and we're going to substitute it into our polynomial here. And we're not going to care about what the actual number is. All we care about is whether or not it's positive or negative, the outcome. So if we substitute negative 3 as x, we have a negative number over here. And then negative 3 minus 3 is some negative number. And negative 3 plus 2 is some negative number. So since we have a negative number times a negative number times a negative number, we have 3 negatives. So overall, the number is going to be negative. So the cool thing about this is that even though we only subbed a negative 3, and we know it's a negative number, it actually tells us that the entire interval between negative infinity and negative 2 is going to be also negative. It's also going to be below the y-axis. So we just do this for the other intervals that we see here, negative 2 and 2, 2 and 3, 3 infinity, and we're just going to see whether or not the interval is going to be positive or negative. if it's going to be above the y-axis or below the y-axis. So let's continue. A number between -2 and 2. The simplest one I can think of is 0. So if you sub in 0 into our polynomial over here, 0 minus 2 is just a negative number, 0 minus 3 is a negative number, 0 plus 2 is a positive. Since we have a negative number times a negative number, which makes positive, positive times positive is positive. So overall, our graph between -2 and 2 is going to be positive. And then between 2 and 3, we can sub in 2.5. 2.5 minus 2 is some positive number. Let's write that over here. Positive number. 2.5 minus 3 is some negative number. And then 2.5 plus 2 is some positive number. So since we have positive times positive, it's going to be negative. And the last one, we have a number between 3 and infinity. Let's choose 4. So 4 minus 2 is some positive number. 4 minus 3 is some positive number. 4 plus 2 is a positive. Since we have all positives, the overall sign is going to be positive. Alright, so since we're looking for the intervals, or the solutions, when our polynomial is less than 0, we just choose the ones that gave us negatives. So the intervals that gave us a negative result is -infinity to -2. You can write that over here. And since it's a less than sign, strictly less than sign, there's no equal, we use a round bracket. And the other interval that gave us was between 2 and 3. So 2 and 3. And that's it. That's solving polynomial inequalities.
Okay, so here we have another polynomial inequality. Notice we have a greater equal sign. And this doesn't actually change anything, the way we do things, in terms of solving the process. Okay. So here we have the example of solving polynomial inequalities. You notice in our example, we do have a greater equal sign. And this actually doesn't change the way we do things, meaning the process of solving our inequality is still going to be the same. But the only thing that changes at the very end is how we write out our answer. Okay, so let's do this. So you might be wondering, if you want our ideal setup here, we want 0 on one side of the equation. So in this case, we don't have that. We have something, a polynomial on one side and something factor on the other. So what we're going to do is you can either move this stuff over to the side, or you can move this stuff over here to the other side. So we complete one of our conditions for our ideal setup. We're actually going to choose, it doesn't really matter which one you choose, we're just going to choose this one because I like having 0 on this side and then everything else on the other. To me that looks a little bit more aesthetically pleasing. So we're going to move this stuff over. Okay. So the big question is, I guess, because this is in factor form, do we need to expand all of this? Meaning, do we have to like distribute everything out? The answer is yes, because later, once we get to getting our factor polynomial, if you notice for all our previous examples, we always had something like a polynomial in standard form, and then our sign equals or greater than, less than, doesn't matter, 0 on the other. And this stuff on the other side is all been expanded out. There's no fractions, there's no brackets, nothing at all. It's just terms like these on this side and 0 on the other. So if you want to move these guys over to the other side, and we do want them all expanded out looking like this, we'll need to expand this out in order to get it looking like this. That way, if we have we can factor it and do our usual business. So yeah, let's go ahead and expand that. To x cubed, 7x squared. Right. Okay. Alright, so let's move all these guys on one side to the other side. That way we'll have 0 on one side, and we satisfy one of our conditions. And minus 2x squared. The negative 2x becomes positive 2x, becomes negative 3x. Awesome. Cool. Now we have 0 on one side. Now to get our factor polynomial. So we have a lot of terms here. So we're just going to collect like terms first, and then we can do our usual business. Okay. So you have 7x squared minus 2x squared, which gives us positive 5x squared, negative 16x plus 2x gets us negative 14x, minus 3x gets us negative 17x, negative 23 plus 3 gets us negative 20. Awesome. Okay, so let's do this. This is where our factor theorem stuff comes in, our long division. So we need our pool of possible factors. So let's write them over here. So our pool. Okay, so 20. Yep, if you don't remember how to get these, we need to list out the factors of our last number here and the very first number over here. So we have positive negative 1, positive negative 2, positive negative 4, positive negative 5, positive negative 10, positive negative 20. For 2, you this. Alright, so I'm not going to write all of the numbers out like I did before, but since just to save some room and save some time, but we're just going to test out all the possible factors are all the possible ways you can match up these numbers with these ones, and we're dividing these with these guys. So meaning it's like 1 divided by 1, positive negative 2 divided by 1, positive negative 4 divided by 1, positive negative 5 divided by 1, and so on and so forth. And if you have positive negative 1 divided by 2, positive negative 2 divided by 2, and all the combinations we can have with those. So yeah. So let's do it. Alright, so we're just going to substitute numbers into here now to see if we get 0. So let's do it. Okay, found a number that works. So the number that worked was a negative 1. So when I shoved it into the calculator, we got 0. Means x plus 1 is a factor. Okay, so now we can get to our synthetic division. To get our quotient or our other brackets, we need to take this guy and divide it by x plus 1. Okay, negative 1, 2. Okay, bring this down. 2. 2 times negative 1 is negative 2. 3. Negative 3. Oh, 20. 20. Positive 20. Nice. Works out. So a good way to check if you did your synthetic division right is if you get 0. If you don't get 0 at the very end, then you probably did something wrong here, or some sort of weird calculation error. Or you might have plugged your number into your calculator and somehow that messed up too. That's actually very common. So either one of these two mistakes. So yeah, the very indication that you got this right is if you have 0 at the very end as your remainder. Okay, so let's write out our brackets now. We are going to erase this. We actually don't need this anymore. Okay, so we have, let's move this over here. So this is the result. We have 2, 3, and negative 20. We are going to remember that. That way, you won't forget it when you write it out. Okay. So you have x plus 1, and then 2x squared plus 3x minus 20. So we have the three numbers here, and remember before, that's why our first term is going to be x squared. The exponent here is going to be 2 because we have three numbers here, and the exponent on our first term is always 1 less than the numbers that we have here. So we start with x squared, and then, yeah, this 2 belongs here, and then work our way down. So 2x squared plus 3x minus 20. Awesome. Alright, so we just continue factoring here until we can't do so anymore. So here we have a quadratic, so you don't need to do our long division. We can just use our whatever way you want to factor quadratics. So we have here x plus 1, and then we have 2x. I think it's negative 5, 3, 4. Ooh. I think it's this. Let's see. Yeah, works out. Awesome. That should be a 5. Not 8. Okay. Alright, so solutions are this. To this are going to be negative 1, 5 over 2, and negative 4. So let's do both ways. I'm going to show you both ways for this. So let's graph. Let's do the graphing one first. Okay, so we have this. You have negative 1, negative 4, 5 over 2. Our polynomial is a cubic, and the leading coefficient is positive, so it's going to go from quadrant 3 to quadrant 1. And because all the orders are 1, you look like this. You can draw it out like that. Alright. So, in this case, we're looking for values that make our polynomial here, x plus 1 bracket 2x minus 5 bracket x plus 4, greater than 0. So how this translates to our graph is we're looking for the parts of our function where it's above the x-axis, so above this line over here. So you can see the parts that are true is this area over here, or this part of our graph, and this part of our graph. So that is in between negative 4 and negative 1. So let's write our interval. So x belongs to negative 4. And since we are using so let's write out our answer now. We have x. That's negative 4, negative 1. Okay, so this is where writing out our answer is a little bit different. So instead of using round brackets, because we're, in this case, we're including our solutions over here, our x-intercepts, because we want greater than or equal to, we, instead of using round brackets, we're going to use square brackets. So this says the numbers are going to be in between negative 4 and 1, that is true, and we also include our x-intercepts negative 4, negative 1, because these guys make our function equal to 0. Okay, and then we have u, and then we have the other section of the graph, so we have 5 over 2, square brackets because we are including the point 5 over 2, our x-intercept, all the way to infinity. And for infinity, we still use a round bracket because infinity is not actually a number. It's not actually a point. It's a concept. And since we can never really obtain infinity, we want to say that like any number greater than 5 over 2 will work. It doesn't matter which number. Then we can use a round bracket to express that. Okay. Awesome. So that's the graphing way. Let's do the other way now. Okay, it's the interval line. Okay. And then we have -4, -1, 5/2. How we do this, remember from last time, we just take numbers in between each of these intervals and we substitute them within our polynomial. And we see whether or not the result is positive or negative. And that actually tells us if the entire function within that interval would be above or below the y-axis. So in between -infinity and -4, we have a point, let's choose -5. So then we substitute -5 in each one of our brackets. So -5 plus 1 is negative. And then 2 times -5 is -10, minus 5 is negative. And -5 plus 4 is also negative. So since overall we have 3 negatives, -infinity to -4, the entire function is going to be negative. Okay. So next one. So in between -4 and -1, let's choose -3. -3 plus 1 gets us a negative number. And then subbing in -3 into here gets also us a negative number. 2 times -3 is -6. Minus 5 is -11. It's also negative. And then -3 plus 4 is positive because we get +1. So since we're multiplying these three guys together, overall number is going to be positive. Okay. So I just did the exact same process for the last two guys that we have in between -1 and 5/2. Between 5/2 and -infinity and infinity, this is the result that we got. So our final answer, these guys, would be, well, we're choosing the intervals that we want to be greater or equal to 0. So that would be these two. And as you can tell, we're going to get the exact same answer as we got with the graphing. X belongs to -4 to -1, 5/2. Okay. Oh, oops. That should not be a square bracket. It should be a round bracket. All right, and we're done.